Hello and welcome to Listening to the Radio.
Today, we're tuning into something pretty interesting, a piece of Soviet-era tech, the RUS-303, a portable radio receiver.
Yeah, and we've got a really kind of eclectic mix of sources this time.
We really do. Everything from, the deep technical specs off a vintage electronics site and Radio Museum user notes, right?
Mm-hmm. And then there's that YouTube video of one actually working, which is great to see.
Plus, and this is the kicker for me, it pops up in a modern experimental music compilation. Very unexpected.
Absolutely. So the plan is to sort of unpack this bit of electronic history and figure out why it might still, resonate today.
Exactly. You might be sitting there thinking, an old Soviet radio, why? But, well, beyond the circuits and knobs, it feels like this thing tells a story.
Yeah.
About technology, sure, but also culture and how the past can echo in weird ways.
It really can. It's fascinating how these objects travel through time, isn't it? Where should we start? Maybe the basics.
Yeah, good idea. Let's ground ourselves. The RUS-303. What's its origin story?
Well, the sources point to its starting life back in 1974, but then it was called the Russia-303.
Right, made by the Chelyabinsk PO Polit factory. Then later, around 87, I got an update, became the RUS-303.
But interestingly, they apparently kept making the original Russia-303 alongside the new one, maybe to keep the product range wider.
Could be. Mm-hmm. And it was classified as a third-class portable radio receiver. What does that actually tell us, that third-class bit?
Well, designations like that usually put it in a specific tier of consumer electronics back then. It suggests a certain level of features, maybe a target price point, not top of the line perhaps, but a solid everyday kind of device.
Okay, that makes sense. And the continued production of both.
Mm-hmm.
Yeah, suggests steady demand, maybe different price points, like you said.
Exactly.
So inside, pretty simple, right? 8 transistors, 2 diodes. Sounds almost quaint now.
It does compared to today's tech, yeah.
Uh-huh.
But it wasn't static. They seem to have updated things over time.
Like what?
Well, components like the loudspeaker, the piezo filter that's part of the tuning circuit, help select the station resistors, capacitors. They were swapped out for more modern equivalents as they became available, it seems.
Huh. So constantly tinkering?
Yeah.
Even within the same model designation?
Yeah, it's that kind of iterative improvement. Why do a full redesign if you can just swap in a better part? It improves performance or maybe cuts costs slightly. It's a subtle evolution.
And we actually get to see one working, thanks to that YouTube video. The person showing it off notes the battery terminals are a bit, roosted, they say.
Chuckles roosted. Yeah, probably rusted. Happens with old battery contacts.
Right. But they hook it up to an external power supply, and bam, it's picking up stations. Long wave, medium wave.
Yeah.
It's really cool to see it still functioning.
Absolutely. Seeing it work just makes those specs feel more real, doesn't it? You get a tangible sense of what it could do. And the rusty terminals, well, they tell their own little story of age and use.
Okay, let's dive into those specs a bit more. It was an AM receiver designed for long wave, medium wave, using an internal antenna for those.
Right, the standard ferrite rod antenna, most likely. Good for those longer wavelengths.
And then for shortwave, the KBSW bands, it had a telescopic antenna you'd pull out. Why? The different antennas.
It's all about the wavelength. Long and medium waves are, well, longer. They can often be picked up reasonably well by a compact internal antenna. Short waves are shorter, more directional, and need that longer external antenna to really grab the signals effectively, especially the weaker ones from far away.
Gotcha. Like needing a different net for different fish.
Exactly, that kind of idea.
Okay, so the frequencies. LW was 150, 408 kilohertz. MW 525, 125, 16 kilohertz. Then 2 SW bands, 9.5, 12.1 megahertz, and 3.95, 7.3 megahertz. Pretty standard ranges for the time.
Yeah, those look like typical broadcast bands covered by portable radios back then. Covers domestic and some international listening possibilities on shortwave.
And it had an intermediate frequency, an IF, of 465 kilohertz. What's the purpose of that? Sounds technical.
It is, but it's a really clever trick used in most radios called a super heterodyne design, instead of trying to amplify and filter all those different incoming frequencies directly.
Which would be complicated, I imagine.
Very. The radio converts whatever station you tune into down to this one, fixed intermediate frequency, 465 kilohertz in this case. All the main amplification and filtering happens at that frequency. It makes the radio circuits much simpler and more effective.
Okay. So it's like a standard internal operating frequency.
You could think of it that way, yeah. A crucial step in the process.
Then we have sensitivity numbers.
Yeah.
LW, 1.5 millivm, and W, 0.7 millivm, SW, 100 millivm, and selectivity. 46 dB for adjacent channels on LWMW. What do these tell us? Lower numbers better for sensitivity.
Yes, exactly. Sensitivity tells you how weak a signal the radio can successfully receive. Lower millivolts per meter or microvolts means it can pick up fainter stations. So it was most sensitive on medium wave, according to those numbers.
And selectivity, that 46 dB.
Selectivity is about rejecting interference from stations on nearby frequencies. Higher dB is better here. It means the radio is better at focusing on the station you want and ignoring the ones next door. 46 dB is, well, it's decent for a portable of that class. Not amazing by modern standards, perhaps, but perfectly usable.
And there were different selectivity numbers for mirror channels. LW 26 dB, MW 30 dB, SW 14 dB. What's a mirror channel?
Ah, that's another artifact of the super heterodyne design. The conversion process can sometimes accidentally pick up a signal at a different frequency, sort of a mirror image relative to the internal oscillator. Good design tries to suppress this, so higher dB numbers are better here too. The SW figure is noticeably lower, which isn't uncommon for simpler shortwave designs.
Okay, so these specs paint a picture of a reasonably capable but not high-end portable radio for its time.
Precisely. It would get the job done for everyday listening.
Then there's AGC automatic gain control. The source says a 26 dB change in the input signal only resulted in a 6 dB change in the output volume. Sounds useful.
Oh, absolutely essential, really. AGC keeps the volume level relatively constant, even if the signal strength fluctuates, like if you're moving around or the atmospheric conditions change, prevents sudden loud blasts or fading into silence, makes listening much less effort.
Right. And audio output, 100 milliwatts, frequency range 300 to 3,550 hertz.
So not exactly hi-fi. That frequency range is pretty typical for AM radio, focused on voice clarity rather than full-range music reproduction. And 100 milliwatts is enough for personal listening from the built-in speaker.
Power came from 4 size, 316 batteries, 1.5 volts each, so 6 volts total. Oh. And the physical size, 215 by 125 by 47 millimeter weight. 1 kilogram, about 2.2 pounds. That YouTube seller wasn't kidding about the weight.
Yeah, a kilogram is quite substantial for a portable. Probably reflects the chassis construction, maybe a larger speaker magnet, the transformer if it had an AC option, just chunkier components overall compared to today's miniaturized tech. You'd know you were carrying it.
Definitely. And the price 59 rubles back when it first came out. Hard to directly compare purchasing power, but it gives us a relative marker.
It does. It fits with that third-class designation, likely affordable for a decent number of people, but still an investment.
Okay, let's shift gears a bit. This is where it gets really interesting for me. The cultural side and these modern echoes. Made in Chelyabinsk, Soviet Union. Radio Museum says 74 to 82 for production.
But other sources hint the RP-303 model from 87 carried on, maybe even alongside the original, and there's that mention of a lilac receiver design variation.
Yeah, it makes you wonder about the aesthetics. Was lilac a popular color for electronics then? It paints a little visual detail.
It does. And the long production run, the variations, it suggests it was a successful product, fulfilling a need for portable information and entertainment.
But then, this connection, the Russia-303, the original name, turns up in the notes for a modern experimental music compilation. Ural Cult. How does that happen?
That's the million-ruble question, isn't it? It's such a jump from everyday Soviet tech to avant-garde music compilation. Why? What's the link?
Exactly. The track is called Olkush Ural-Siberian Hum, and the description says it uses a sample of a Taiman folk song. Okay. But then layers in the sound of an old Soviet Russia-303 radio.
The sound of the radio itself, not just playing music through it, but incorporating its sonic character.
Right, along with guitar effects, synths, and apparently the radio sound interacts with the other instruments. It even breaks the hum and loops at some point. So it's not just background static, it sounds like an active element.
That suggests a really deliberate artistic choice. Using the radio's inherent sonic qualities, maybe the tuning noise, the specific crackle, the limited frequency response as part of the musical palette itself.
And the compilation's overall theme, exploring acoustics of sacred spaces, natural phenomena, drawing parallels between ancient sounds and experimental music, including this humble Soviet radio, feels significant.
It really does. It connects this piece of mass-produced everyday technology to these much grander themes of sound, place, memory, maybe even ritual in a modern sense. Perhaps the radio acts as a sonic artifact, grounding the experimental sounds in a specific historical and cultural context.
Could the hum in the track title even be a reference to the radio's own electronic hum?
That's a really intriguing thought. It could be. Or maybe the radio represents a kind of persistent background noise of a particular era, a cultural hum.
And connecting back to that YouTube video, the seller mentioning the weight, having the original manual and diagram, it adds to this feeling of the radio as a physical artifact.
Definitely. Those tangible elements, the weight in your hand, the paper manual, contrast sharply with how we usually experience audio digitally today, doesn't it? It reinforces the radio's historical presence. The manual and diagram, that's the complete package from its time.
So wrapping up our deep dive on the Rossier RP303, what are the main takeaways here?
Well, I think we've seen it's definitely more than just an old radio. It's a snapshot of Soviet-era consumer electronics, reflecting the engineering and production realities of the time.
Yeah, with specific technical capabilities, a history of ongoing updates, suggesting it was a pretty common part of life.
Right. But then there's that unexpected second act, isn't there? Its appearance in contemporary experimental music.
That's the bit that really sticks with me. How this object and its sound can leap across decades and context to find new meaning, to become part of a new artistic conversation.
Exactly. The tech specs tell us what it was, but the cultural context, and especially this modern usage, tells us something about how objects can accrue meaning, how they can carry echoes of the past into the present and inspire something completely new.
It really makes you think, doesn't it? About the stuff we have around us, maybe tucked away in boxes, old gadgets, technology from our own pasts.
What stories are embedded in them?
Yeah. Could that old Walkman, that first brick phone, find some unexpected relevance later? What narratives might still be waiting inside the forgotten tech that surrounds us if we just, stopped and listened?